Hello everyone, welcome to this lecture number 3 of Unit 5 Flexible Manufacturing System. In this lecture we are going to see Introduction to this Robotics. Okay, this is Mr. Suyog Patil working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkaranji. Today we are going to see this robotics. What is mean by robotics? What are the different drives used in the robotics? Okay, the sensors used in the robotics. That part we will cover in this lecture. First of all, we will see what is mean by robot. A robot, or again we can see the definition of this robot here. A robot can be defined as a programmable or self-controlled device consisting of a electrical or mechanical units. Okay, this robot is nothing but it is a programmable self-controlled device or a machine. Okay, consists of electrical and mechanical parts, and again we can say this mechanical apparatus designed to do the work of this man. Okay, the machine or the apparatus designed do the work of this human. So that machine is nothing but the robot. Basically nowadays in this various industries, this humans are or the operators are replaced by this robots. Okay, that means this human work is carried out by this robot. Then its components are usually electromechanical and are guided by this computer program or electronic circuits. Okay, so that means these electromechanical components are used to form this robot, and these robots are computer guided. Okay, then to generate the specific motion of the joint, to integrate the tooling and sensors to operate this or to do the work of this human, basically these robots are used. Okay, these are the functions of the robots. Now here we can see these are some of the images or some of the figures of these robots. Okay, so this is the automobile, or we can say the mobile vehicle type robots. Okay, the human robot which is used to do the work of the human. Okay, so again it is a kind of the human robot. Arms are used here. So this is the pick and place type of these robots used in the various industries. Okay, these are the some images. Then degrees of freedom. Okay, so again this various degrees of freedoms are required in these robots. So this degrees of freedom is a of a rigid body is nothing but the number of independent movements it has. Okay, the machine or the robot, the independent movements it has, number of independent movements. So that number of independent movements are nothing but the degrees of freedom of that rigid body or of that machine or of that robot. Then again, higher number of degrees of freedom indicates the increased flexibility of the positioning of the tool. Okay, in case of this robots, if it has a high number of degrees of freedom, that means it is very flexible. Okay, very flexible. Flexibility of this robot is higher. For each degree of freedom a joint is required. So here we can say for up and down, or for left right, or for forward and backward. Then again rotational degrees of freedoms are will be there. Okay, for each degrees of freedom one separate joint is required, and the degrees of freedom located in the arm defines the configuration. Okay, there are different configurations in this robot. So each degrees of freedom defines a separate configuration as well. As then total number of 6 degrees of freedom is needed to locate a robot hand at any point in its workplace. Okay, total 6 number of degrees of freedoms will be there, and these 6 number of degrees of freedoms are needed to locate a robot's hand. So these are the degrees of freedom of a robot. Then next point it is robot configuration. Okay, so as this robot configuration is related with this degrees of freedom. So basically the robot manipulator has two parts. Okay, one it is called as body and arm assembly with the 3 degrees of freedom, and second one it is nothing but the wrist assembly with 2 degrees of freedom. Okay, so these are the two main parts of these robots, and based on this, again, this degrees of number of degrees of freedom and this robot configuration is related. For body and arm configurations, different combinations of the joint types are possible for a 3 degrees of freedom robot manipulator. We will see one by one in detail. So this is nothing but the robotic arm configuration, in which the first kind type is Cartesian coordinate system. Okay. So here we can say in this Cartesian coordinate system, so there are three orthogonal directions, x, y, and z. Okay, so here we can say x direction, y direction, and z direction in Cartesian coordinate system. So this robotic arm will move along this positive x and negative x direction, along this positive y and negative y direction, and along this positive z and negative z direction. Okay, that means this arm will slide along this x, y, and z direction. So x coordinate of this axis may represent left and right motion. Similarly, y coordinate represents the forward and backward motion of this robot, and this z coordinate represents the up and down motion of this robotic arm. Okay. So example of this type of this configuration is a overhead crane in the industry. Okay. So moment of this overhead crane is based on this Cartesian coordinate system. So that means this robot will move up and down. Okay, this will move up and down. Then this will slide along this z direction, y direction, as well as this will slide along this x direction as well as. Okay, so this is an example of this Cartesian coordinate system. An application of this type of this configured robot is pick and place robot operation. Okay. Second type is cylindrical configuration robot. Then it uses the vertical column and a slide that can be moved up or down along the column. Okay, so this is the cylindrical slide, which is, and this slide is placed on this cylindrical base. Okay, so this slide will move up and down along this z direction here. Okay, then again this will move along this y, and this will may turn along this vertical column and in the degrees of freedom theta. Okay, the robot arm is attached to the slide so that it can be moved radially with respect to this column. Okay, so that it can be moved radially with respect to this column along this column axis. Okay, then by rotating the column, the robot is capable of achieving a work space that approximates the cylinder. Okay, so then again it contains two linear motions and one rotational motion. Here we can see this up and down direction, that means along the z direction, along the y direction, again it can be moved. These are the two linear directions, and this can rotate about this axis by theta. So this is the third direction. So here we can see this angular motion theta along this vertical axis, then translation motion along the z axis, and radial direction in the R. In application of this type of this configuration of the robot is it can be used in die casting, then inspection and molding applications. This type of the robots are used. Third type is it is polar configuration robot. So here in this figure we can see this polar configuration robot. It uses a arm that can be raised or lowered about a horizontal pivot. Okay, along this horizontal pivot, this can be raised or rotated along this pivot. Then again, this pivot mount is on a rotating base. It is mounted on the rotating base, and various joints provides the robot with capability to move its arm within a spherical space, and hence it is also called a spherical coordinate robot. Okay, so this type of this robot configuration is also called a spherical coordinate robot, and it has a one linear and two rotary motions. Along this x direction it can move linearly, and this can be moved in rotational direction. So application of this type of the robot is glass handling and machine tool handling robots. Okay, next type of this arm configuration is jointed arm configuration. Okay, so this jointed arm configuration is similar to that of this human arm. Okay, here in this figure we can see this is the jointed arm configuration where these three joints are used to form this jointed arm, and these components are connected by two rotating joints corresponding to the shoulder and elbow. Okay, here one joint and second joints are provided. A wrist is attached to the end of the forearm, thus providing several additional joints. Okay, here we can see this is the wrist provided to form this robotic arm, jointed arm configuration. Next point, robotic drives. Okay. So any device that introduces motion into a system, so that is nothing but this robotic drives. There are major three drives. One it is hydraulic drive, pneumatic drives, and electric drives. Okay, we will see one by one. Hydraulic drives. Okay. An actuator that uses pumps, valves, and pressurized liquids to create a mechanical motion. In these hydraulic drives, this pump, valve, and pressurized liquid is required to create this mechanical motion, like a mechanical movement. Then it delivers a large power to the joints or tools. The power transmitting capacity of this hydraulic drive may be up to 225 pounds. Then for explosion proof robots, this hydraulic type of the drives are used. The, again this type of this drive has a higher cost. Then again it requires pump, reservoir and valves. Then for higher pressure work, so again it introduces some cost. Then application of this type of this drive is in spray painting, then welding, spot welding, then handling heavy forging and die casting operations. This type of the hydraulic drive robots are used. Second type is pneumatic drives, an actuator that uses pressurized air to create a mechanical motion in case of this pneumatic drives. Then it is least expensive because this air is very or conveniently available in this air. Okay, then again it uses air, so it is least expensive. The components are easily available. Then the payload capacity of this pneumatic type of the drive is up to 5 pounds. Okay, less capacity and speed is very high in pneumatic drives. The air pressure is approximately 90 psi in case of this pneumatic drives. Here in this figure we can see, so the pick and place type of the robots are the in this pick and place type of the robots, these pneumatic drives are basically used. Application is pick and place robot. In electric drives, an actuator that uses electricity to create a mechanical motion. Here we can see the more precise and more accurate. This type of the drives are more precise and more accurate because it has a less number of these moving components. Then again can be programmed or complicated paths motion. These electrical drives are used where these complicated path motions are required. Then incorporated feedback control loop. Then sensors like optical encoder continuously monitors the position of this robot, and this can be controlled very easily. Then continuous and smoother movements is there. So application of these electrical drives are general purpose applications, then automatic assembly operations. In these operations, these electrical drives are used. So here, so servo drives. So pneumatic, hydraulic and electrical drives, their scope and benefits, advantages are explained here. Summary. So in this lecture, we studied about this robot. And robotics is an integration of these computers and controlled mechanisms to make these devices reprogrammable and versatile. Okay. Then modern mathematic representations are used to plan robotics, then tasks, and integrate the sensors into the task planning. There are there are decided advantages to use these robots, namely flexible and performance quality. To improve this performance quality and to use this flexibility of these robots are basically used in this various industries. Then downside is that robotic affects the labor pool and increases the educational requirements for manufacturing personnel. Robotics are used in most industries and will be used even more in it decides decades to the come. Thank you so much. Friends, thanks for watching this video. If you like this video, please share, comment and like this video, then subscribe to my YouTube channel and click on the bell icon to get notified for more videos on this CAD/CAM subject. And thanks for watching. Thank you so much.